The control of acidic variance in cation exchange chromatography, or CEX, relies on the underlying chemistry of ionic interactions, particularly the charge differences between the main monoclonal antibody form and its acidic variance. Here's a deeper look at the chemistry involved. Acidic variants in monoclonal antibodies are typically forms with modifications that introduce more negative charge, such as deamidation, which is the conversion of asparagine to aspartic acid, sialylation, which involves the addition of negatively charged sialic acid residues, or fragmentation. These modifications reduce the overall positive charge of the variant compared to the unmodified monoclonal antibody, making it more acidic. At a given pH, the acidic variants will therefore have a weaker positive charge than the main monoclonal antibody, which affects their interaction with the CEX resin. In Cation Exchange Chromatography, the resin is functionalized with negatively charged groups, such as sulfonate groups, which attract and bind positively charged species, like monoclonal antibodies. At a specific pH, both the main monoclonal antibody and its acidic variants are positively charged, but differ slightly in their charge densities. This difference affects the strength of their binding to the resin, allowing for their separation. The isoelectric point of the main monoclonal antibody form and its acidic variants governs their net charge under different pH conditions, which is key to selecting an effective separation pH. The pH of the buffer in CEX is chosen to ensure the mAb and its variants are in a protonated state, or positively charged. However, small charge differences between the main mAb and acidic variants cause them to bind with different affinities to the resin. As a salt gradient, such as NaCl, is applied, the positively charged ions from the salt compete with the mAb molecules for binding to the negatively charged resin. Variants with weaker positive charges, or acidic variants, are displaced more easily and elute at lower salt concentrations. During the salt gradient or pH adjustment, acidic variants with lower net positive charges elute earlier than the main mAb form because they are more readily displaced by the increasing ionic strength in the mobile phase. The strength of the interactions between the resin and the mAb, or its variants, decreases as salt concentration increases, leading to a sequential elution based on charge differences. A shallow salt gradient provides finer control, allowing better separation between closely related charge variants. Precise control over pH and conductivity is critical to maintain a consistent elution pattern, ensuring reproducibility and purity of the mAb product by efficiently isolating acidic variants. The chemistry behind controlling acidic variants in CEX involves fine-tuning the ionic interactions between the negatively charged resin and the differently charged mAb forms. By carefully selecting the buffer pH and applying a controlled salt gradient, acidic variants with lower positive charge are selectively eluted before the main mAb peak. This enables effective removal of acidic variants, resulting in a purified mAb product with improved quality and consistency.